Well, Regina Obey,
Yeah.
fancy meeting you here on the internet.
Don't we always meet? No, we
It
don't.
is always where we meet. That's true. Anyways, nice to have you in my internet presence. I understand you're going to give us a surprise.
Yeah. Well, hopefully it's a surprise.
Okay, lay it on us.
Okay. All right. So everybody knows who I am, hopefully. I've written a bunch of books over the years, and I am still writing a bunch of books. So the two I'm working on, which I have been working on for a couple of years, is the PG routing second edition, and that's going to cover 3.7, which was recently released, and the upcoming 4.0. So we're going to try to time it at the same time as PG Routing 4.0 comes out. So the other big announcement I have is PG Routing used to be a community project of the Open Source Geospatial Foundation, but this year, last month or so, it got promoted to an official project, which means now it gets some funding from OSGO. And I'd like to make a public service announcement, and that is lots of us depend on open source software. And in order for open source software to improve, it requires investment in both time and money from people. And what's often said about open source is that it is not a business model, which is true. It is a public service model. And like all public services, it requires both time and money from the community of people that benefit from it. So if you find that you have benefited, you can invest directly in OSGO projects or PG routing. And the links are here. And I'd also like to give a big thank you to osgo.uk, who has invested thousands of dollars in PG routing and is continuing their investment this year. One of the other things that I'm known for is I manage the PostGIS Windows bundle. So if you ever see this screen on Windows, you're using work I've done. So I basically package a whole bunch of PostGIS related extensions for Windows. And here's a list of all of them that are part of the bundle. And I also try to push other packagers to package PostGIS extensions. And I've been, I think, for the most part, successful. And so you will find other extensions on apt and yum that are spatial. So you'll see point cloud, you'll see PG routing, you'll see OGR FDW, you'll see most recently H3 and mobility DB are now available on apt. And I think yum is coming up very close. And you also find many of these much less so on database as a service. Crunchy data is great in the sense that they have pretty much all of them, whereas uh, the other DBAS have don't have all of them. They have the core PostGIS ones, but not everything, not the other extensions. Okay, so now we go on with the show. If you want to follow along, the SQL file I have is here. And the first big surprise is I am running PG admin in a browser. And for desktop, you'll notice that whenever, I forget when the version came, it used to run in a browser, but it switched over to running as a self-contained application, but it's still essentially an application that runs in a browser. And the trick to get it to run in your favorite browser is described in this Stack Overflow. And why would you want to do this? Well, if you have other things you're showing, like your presentation, in my case, this, and also you have other HTML things that you want to show. It's much easier if everything is running in your browser, because then you could just tab and you only have to share that one window. And so I'm going to continue from where I left off last year, covering the extensions I didn't get a chance to cover. So the usual thing you do is check what version of PostGIS you're running, right? And then you create your database. You set your search paths. I like to install PostGIS in the schema called PostGIS just to keep it separate from my other stuff. And I tend to install things that are directly related to PostGIS in that schema. And even though Address Standardizer comes with PostGIS, it has no dependency on PostGIS. So I tend to put it in the contrib schema. And what does Address Standardizer do? It takes addresses and it standardized them based on a set of gazetteer rules and lexers. And these are defined for the US in a separate extension called Data US. And we haven't developed for other countries, but the Data US tends to work okay for British Columbia, Canada. So if you look at the output, it basically takes whatever address you have and it parses it into the different things. And it expands the suffixes if they're not already spelled out. And numeric things, it will convert to a number. So you'll see the units number 5 floor instead of 5th floor. And Paul had asked last time, can you do this with French Canada? And the answer is kind of. So if you look here, it more or less breaks it out more or less correctly. However, it kind of sucks on with French characters. So French characters totally screw it up and you get something that doesn't make sense. So that's one of those things we have to improve on. And I think that's an internal change that needs to be done. In PostGIS 3.4, I introduced a function called debug standardized address. And what that does is it basically looks into the brain of the address standardizer to see how it's tokenizing the different parts of the address. And so what the tokenization does, it basically takes each word and it categorizes it. Is it a number? Is it a street? What part of the address does it fall into? And you can expand this out. And I'm going to start going really quickly because I want to get into other stuff. So the other extension that I work heavily on that I manage is the Tiger geocoder, and that's tied to the Tiger census data, which interestingly enough is a structure that's based on the SQL topology, which is the same structure that PostGIS topology uses. So they have edges and faces and things like that. And the current Tiger geocoder that's packaged with PostGIS is for 2023 data, but they recently came out with 2024. And for the most part, I think if you just change the year to 2024 and the URL, you can load 2024 data. I don't think they changed it that much since last year. And then once you have the data loaded, you can then geocode which somehow I managed to screw that up. So I'm going to skip that. You can also reverse geocode. And the reverse geocode basically it does the reverse of geocoding. It takes a long lat and it converts it to an address. And all this is using linear referencing. So it's not exact because it's just using the edges and interpolating the address based on the start and end of a location. And you could also geocode by intersections. And so the next extension I'm going to cover is PostGIS SF Siegel, which Lloyd talked about earlier. And in 3.6, there's major new enhancements to it. The other thing that happened with PostGIS SF Siegel in 3.5 is we standardized on the prefix CG. so that it's separate from the other PostGIS. So you know, if you see CG, then it's a SFC Go function. If it's ST, it's going to be PostGIS proper. And the old ones still exist. The old ST still exists, but they're deprecated now. So moving forward, you should be using the CG prefix. Let's see, why does this not work? Okay, so one of the new functions in 3.6 is the buffer, the 3D buffer, which I'm especially excited about because whenever I talk about PostGIS, I say we study the globe, the Earth globe, and it's kind of embarrassing when you can't draw a globe with the thing that you're using. So that's one of the great things with having buffer. If you buffer a point in 3D, you get a globe. And this is kind of a dumb globe. And the reason for that is because of this segment argument. I'm using 10 segments to approximate a segment. I mean, 10 edges to approximate a curved segment. But if I increase that to, say, 64, I get a more convincing globe. So it's smoother, it doesn't have all those edges on it. And just a note, so the function I'm using to view the 3D is a function I created a while ago called STS3D, and X3D is a standard that was born from the virtual reality VRML standard, and it is a Web3 standard, and it's going on to version 4. But the idea is that you can basically use a web browser with very minimalist JavaScript to create 3D scenes and also to interact with HTML elements. So one of the other functions, and this has existed for a while, is the extrude function, where you can take a 2D object and you can extrude it. And that was one that Loic had mentioned about creating building footprints, like elevating based on the height of the so you basically take, so here I'm taking the letter G and I'm just extruding it. And what's new, what was new in PostGIS 3.5 is this extrude straight skeleton. And this is used mostly for drawing rooftops. So if you look at it, you take the same more or less, oh, actually, well, we take the same G, and if we use the straight skeleton, you can see it kind of creates a roof curve, and you can fiddle with the arguments to see what you can get. So there's the roof height and the body height. All right, next function, next extension, which I always talk about, is the OGR FDW. And OGR FDW is a foreign data wrapper that builds on the GDAL vector support. So it's basically OGR to OGR, which was covered in earlier talks, except running in the database. And to see what version you're running, you use this function. And the GDAL version tells you, basically, it defines what drivers you'll be able to use. So one of the new drivers that came in GDAL 3.8 is the GTFS standard, and I'll cover that in a bit. But one of the old standards is the GFX, which is basically GPS points stored as XML. And this is very useful if you're using something like mobility DB, and so you want to see your trip, and you want to figure out what speed you were running at each part of it. And so now we get into GTFS, which I already built this, so I'm not going to run that. But GTFS, when you run this, you can actually have the zip file. You don't need to unzip it. So this is the Massachusetts MBTA. And if you look at where I have it, remember these are all linked tables. So they're not physically in your database, but you have 32. So there's a lot of rich information in this format, this general transit feed specification. And you'll find lots of cities have this data. It's got things like scheduling, and then there's like a real-time version of it where you can get real-time traffic and all that. And so when I look at this, I just want to figure out which tables I want, and I pull them in. And with that, I can also I can use this both for PG routing, I could use it for mobility DB. But I'm going to skip all this because I already did this. So let's talk about PG routing first. So PG routing, as was mentioned in the earlier talks, is an extension that leverages PostGIS and has a lot of routing algorithms. And essentially, PG routing leverages Bootstrap. So it's really a wrapper around Bootstrap. So if you think OGR-FDW is a wrapper around GDAL, SF Siegel is a wrapper around Siegel, PG routing is a wrapper around Bootstrap. And one of the changes that's new in the later 3 series is this function called extract vertices, which is going to replace the create vertices. And let me just take a look at what that returns before I go through. So basically what this returns, you can use it in 2 ways. So if you have a geometry in there, it will use the geometry to compute node numbers, right? It would ignore the source and target nodes you have. If you use source and target, it will infer that those are nodes, and it will give you all this other information, which tells you how many edges are inbound to a node and how many are outbound and so forth. So if you already have your nodes, you would use this format, and then I could use this information to update all these other attributes. And one of the other functions that's relatively new in the 3 series is the connected components. And connected components tells you in an undirected way which nodes can get to which other nodes. So the component is the lowest node. Is it the lowest node or is it the lowest edge? I forgot. And then there's the strong components, which tells you in a directed way what things can connect to what things. So actually, let me just take this just to demonstrate a quick thing instead of doing my counts. Star. So basically, the component is the lowest numbered node. Or is it the highest number? Anyway, it's a node, and all nodes within that have the same component are reachable from each other. So it basically guarantees that if you're part of the same component, you can get to anywhere from anywhere in that component. And let me see what else. Okay, so I'm going to skip all this because I'm running out of time. So one of the good things to do, useful things to do, is to add a component to your nodes and edges tables. And what that tells you is you can quickly tell which nodes can reach other nodes and which edges are reachable from other edges. And why this is important is the MBTA data I have, because I didn't load it completely right, and for other reasons, has a lot of disconnected pieces. So I can tell from here, like if I'm on Park Street, I can get to Downtown Crossing and this Kendall, but I can't get to Chinatown. So I don't even have to do a route to know that I can't get to those places. And so if I were to route, one of the popular things is to just get the cost of going from one place to another. And if you want to see the actual steps, you'd use the Dijkstra function. And if you want to compute, you want to see the full path visually, you would join it back with your edges table or your points table. Which, let's see. And one of the other things, because graphs it gets loaded in memory and it's the thing that takes the longest to build. There are multiple forms of the Dijkstra and other algorithms that allow you to do multiple paths in a single call. So you build the graph once and then you could do multiple routing steps in a single call. So I think I've run out of time. Does anybody have questions?
You still have a little bit of time if you want to knock off one more section there.
Okay, let me see. All right, so let me knock off mobility DB because that was something that was discussed. And as we said, it basically leverages PostGIS, but it puts in temporal in a very readable way. So in PostGIS, we use the M for managing trajectories, whereas mobility DB manages it directly with time. So in PostGIS Windows, the latest version is 1.2, which recently came out. And I'm going to look at my GPX data that I loaded. Quickly create it. And one of the neat features of it is you could do a couple of things. So in this, I'm doing a whole bunch of things. I'm checking the speed, and what it returns is what's called a temporal float. And it basically shows you at each segment what speed you are going. And you can also convert back to geometry, the PostGIS line string M format if you want, and it stores the time in epic format. And it also has these cool aggregate functions because the speed thing is kind of hard to use in most things, but you can get the average weighted speed. And so you just get a single numeric number. And there are a whole bunch of other functions that do that. So you could take the duration and see what else. Oh, actually, so this other function that I forgot to point out. This at time is a very interesting thing. It's basically, it shows you the points in your, the list of points that fit in that range of time that you define, that time span. Okay, now I think I'm pretty much out of time.
Okay. What do you have on your PostGIS agenda for this year?
Okay, so the first thing is, well, I first have to make sure that Tiger Geocoder
Yeah.
works with 2024, which I think that's easy. I'm gonna try to improve the X3D, STS X3D, because I think I have some rough spots in there, and make sure I don't need to add anything because the X3D 4.0 came out recently, was finalized. So I want to make sure that I have all that covered, whatever new features they have in there. I don't think they've changed how you render. It's more of the animation part of it that's changed. And what else? Um, I'm sure there's some other things I'm forgetting. Yeah, I'm sure there's a lot of stuff I'm forgetting.
What happened in the last year that made you go, ooh?
What happened last year that made me
Yeah,
go,
what
ooh?
technical thing has changed in your world that's made you go, ooh?
I don't think anything. Last year was kind of a very uninteresting year. Aside from the SF Siegel stuff, I think everything was kind of boring.
Yeah.
But I'm looking forward to the new Siegel stuff.
Hmm. Do you have customers who use volumetrics?
Not so much, but they want to. So it's
Okay.
just getting to that point where it's easy and fast
Yeah. Will it ever
and
get to
has all
that
the
point?
fun. I don't
It's
know.
easy and fast.
Is anything ever easy and fast?
Well, you
I
need the
think
right
it
set to
depends.
function. I always
Yeah, I
wanted,
mean, it's always the functions and it's always the graphical piece, right? That holds things up.
yes. I was going to ask that question. I guess I ran out of time in the SF Siegel. That's for the Auslandia folks, which was like, how do you look at how do you work with this stuff and look at the results? It's not you can't just fire a query into QGIS and see the volumetrics.
I think they have a 3D viewer in QGIS actually. I don't use I like X3D just because I like the idea of being able to render. So similar to Martin's SVG, like X3D creates fragments of X3D, and so that's my dream is to have it native in the web browser. So you don't even need JavaScript to look at it.
Right. Well, we'll see if your dream is realized. Could you make sure you put your URL of FunSQL into the chat and
Oh, okay.
into the
Yeah, let me
question, into the
see.
Q&A box as well, so that
I
we
think
have
I
it for everybody?
lost
It kind
somehow
of zoomed
my,
by.
yeah, my where the hell's my, yeah, somehow I lost my, oh wait, is that, okay, there it is. No, Q&A. I can't find the chat.
That's
Yeah,
okay.
somehow,
Just put it
yeah,
in the
somehow I
Q&A.
lost. Oh, actually, no, I do see the chat. Okay, hold
Okay.
on. Let me.
There it is.